Know the difference between database, data warehouse, and data lake. Let's start with database. So the database is an electronic storage that stores organized, structured data which helps in tracking the business. Next is data warehouse. The data warehouse is periodically loaded with data from the database, a special type of database optimized for reporting and analysis. It is said that it is a type of storage that is loaded with data from database. It is also used often in reporting and analyzing. Data warehouse is also known as central repository of information that can be analyzed to make more informed decisions. Before we proceed to the data lake, let's first discuss what ETL is. Extract, transform, and load. ETL is the process of taking your database data and loading it to your data warehouse. To make it simple, it is a process where you load your database into your data warehouse. And now let's discuss data lake. A data lake is a storage repository that allows for the storage of all types of data. The data lake is useful for unstructured approaches like machine learning and artificial intelligence. So the data lake is basically a storage where you can stock all types of data, even though it's not that important because it might be useful for future purposes. Now let's proceed to the examples of database, data warehouse, and data lake. In the database we have SQL Server, Oracle, Microsoft Access, and Excel spreadsheets. And in data warehouse is SQL Server, while in data lake we have ORS, Microsoft Azure, and Google BigQuery. And here are some programs on how you can access them. In database we can use SQL, and in the data warehouse we will use Power BI and Excel spreadsheet. The last is data lake, which we can use Power BI and Python. That's all for week 1. Thank you for listening.
Next is week 2, the data warehouse. The data warehouse is a set of tools and techniques to collect data about the different business operations, integrate the data, prepare the data in such a way that it allows the users to derive insights from the information, thus enabling business intelligence. Features of a data warehouse are as follows. First, stores large amounts of historical data. Second, data model optimized for analytical queries. Third, flexible in handling changes to data sources. Fourth, serve as a base for various needs such as OLAP, data mining, predictive analytics. Lastly, single source of truth for other systems. Architecture of a data warehouse. First layer calls is data source layer, second is data warehouse layer, and the third is presentation layer, which all play their parts for securing the data. In the absence of a data warehouse, this will cause data consistency not guaranteed, duplication of work on interface building, and no single source of information. All these factors can cause burden on the data sources and their owners. Benefits of a data warehouse. It accesses a single source of truth for analytical needs in future systems. Next is consistent of reporting information. Last is it can access the data easy and secure. To summarize, running a business and measuring the business are distinct from each other. They each demand different skills, different thought processes, and different software to manage them.
For this lesson we will be discussing the phases in data modeling. So before that, let me define first what is a data model. Data models are visual representations of an enterprise's data elements and the connections between them. By helping to define and structure data in the context of relevant business processes, models support the development of effective information systems. They enable business and technical resources to collaboratively decide how data will be stored, accessed, shared, updated, and leveraged across an organization. The purpose of a data model is: data models play a key role in bringing together all segments of an enterprise, business analysts, management, and others, to cooperatively design information systems and the databases they rely on. These systems require properly defined and formatted data, and models shine a clear light on what data is required and how it must be structured to support the desired business processes. By explicitly determining the structure of your data, these models support a variety of use cases, including database modeling, information system design, and process development in support of a consistent, clean exchange of data. It's also important to understand the 3 different types of data models. Each will serve a different purpose as you work through the data modeling process. These are the 3 stages of data model. The first stage is conceptual data model. Conceptual data model is a structured business view of the data required to support business processes, record business events, and track related performance measures. This model focuses on identifying the data used in the business but not its processing flow or physical characteristics. Additionally, it also known as domain models, that explore and detail your high-level, static business structures and concepts. They are most frequently used during the beginning of a new project, when high-level concepts and initial requirements are hashed out. Often, they are created as precursors or alternatives to the next stage, the logical data models. The next stage is logical data model. The logical data model establishes the structure of data elements and the relationships among them. It is independent of the physical database that details how the data will be implemented. The logical data model serves as a blueprint for used data, and after your problem domain and initial concepts become more clear through conceptual data modeling, it's time to get more specific with a logical data model. Whether you're looking through the lens of a single project or your entire enterprise, these models clarify the various logical entities, types or classes of data you'll be working with, the data attributes that define those entities, and the relationships between them. Last stage is physical data modeling. Physical data model is a database-specific model that represents relational data objects, for example, tables, columns, primary and foreign keys, and their relationships. A physical data model can be used to generate DDL statements, which can then be deployed to a database server. And when you get to the physical data modeling stage, it's truly time to get down to the nitty-gritty. These models are used to design the internal schema of a database. That includes all of the various tables, the columns on those tables, and the relationships between them. These models will be directly translated into production database design, which will support further development of information systems. Physical data models generally are used to design three types of databases: relational for traditional operational databases, document for NoSQL and JSON databases, and dimensional for aggregation and business intelligence data stores such as data warehouses and data marts. Ultimately, all three models can and should work independently of each other. But as your project matures, the best results will come from a natural progression through all three models. Of course, consistency must be maintained across the models on a structural level. Adjusting the table column format on a physical model, for example, should not change the initial conceptual model in any meaningful way. By leveraging all three models, organizations can ensure their projects do not lose sight of initial objectives, but still maintain the flexibility to address unexpected changes in requirements or parameters. And that's all for the phases in data modeling. Thank you.
On this video we will discuss the concept behind the dimensional modeling design. So what is dimensional modeling? Dimensional modeling is a data modeling technique used in data warehousing that allows businesses to structure data to optimize analysis and reporting. This method involves organizing data into dimensions and facts, where dimensions are used to describe the data, and facts are used to quantify the data. For the data model, the term data model refers to the way data is organized, documented, and defined within a database. So we have mentioned the database. The operation of database are primarily of two types: the write and read. Let's represent the write. The write can be optimized with large number of small tables, while the read operation can be optimized with small number of larger tables. Let's proceed to data model diagram. The data model diagram is used to create or view graphical models of relational database system schemas, including a range of database objects. The diagrams can be drawn at a logical or a physical level. Also, data modeling is the process of producing a diagram of relationships between various types of information that are to be stored in a database that helps us to think systematically about the key data points to be stored and retrieved, and how they should be grouped and related. So let's talk about the normalization and denormalization. Normalization is the technique of dividing the data into multiple tables to reduce data redundancy and inconsistency and to achieve data integrity. On the other hand, denormalization is the technique of combining the data into a single table to make data retrieval faster. Next is for the dimension and facts. Dimensions are companions to facts, and describe the objects in a fact table. Facts are stored in fact tables, and have a foreign key relationship with a number of dimension tables. Lastly is for the summary of the whole topic about the dimensional modeling. 1. Dimensional modeling is applicable only to data warehouse. 2. Dimensional modeling emphasis is on read operation. 3. Dimensions and facts are the basic building blocks in a dimensional modeling. And that's all for the week 4.